this computer. Okay, thanks everyone. So we'll go over some TypeScript stuff. So a lot of this you probably already know. Some of it you might not. Some best practices kind of stuff. So I'm just going to go through and hope you guys learn something. Okay, so first thing on my agenda is how to pull types from Swagger using our Ngswag Studio. So actually probably would help if I shared my screen, huh? Okay. So almost all of our projects will end up getting something that looks like this, where we get a Swagger endpoint and the backend guys, here's all our APIs, it's all well documented, and the backend guys spend a lot of time, figuring out the models and stuff like that. And so it can be a lot of work to actually convert this into interfaces. Better close that. It can be a lot of work to convert that into interfaces and type it all in models. So the nice thing is we have a tool called Ngswag Studio, which I'll pull up here. Which will actually generate all your models automatically from a remote endpoint. So to start, so let's go here. So I'm on my Swagger endpoint. You'll notice at the top here, I have a link to what's called swagger.json, and this is our Typescript definition file. So if I do copy link address, all right, and we put it in this guy right here, and let me go ahead and just go over some options. So we want to generate Typescript. All right, get this out of the way here. Okay. And then just a couple of configurable options. We don't need to generate classes. We just want interfaces. All right. We want the DTO types, but we want to generate them as interfaces. Null, everything else is OK. So what we do is we click generate outputs. It's a big project. OK. And if you notice, what it's done is it's generated all my interfaces and enums directly from the web API. And so what I like to do is just select all, copy paste, and put them in a models file inside your project. So if you'll notice, there's a couple problems with the way Ngswag Studio likes to generate. So if you look, let me just show you how many there are here. There's hundreds, like substantial number. Take a lot of time to update these. It also takes a lot of time for these, when these also often change fairly frequently. So a couple patterns that I like to do is I like to wrap all these in a module just for convenience. So I'll show you what that looks like. So so you've got two main options when you want to bring them into your project. You can use a namespace or a module. The big difference is that namespaces are not compiled where modules are. So if you were not putting enums or something in there, it would, namespaces would be your better choice, just because they're not adding more more space to your project. But the advantages of having them in modules is that you can still access your enums and stuff. So you're going to do something like export module models. OK, a lot of you have probably seen this pattern already. And then what I do is I just copy paste, bring all these guys in. And now all of my models for this project are available via, models dot, if you notice here, they're all here. So a couple people don't like to wrap stuff in like a wrapper like this. The reason I like to do that is so like when I import like 50 models, I don't want to have to import like 50 interfaces into like a single project. Far better to just import one. And so this way is they're all accessible. The other thing that's useful to do is sometimes we need to create our own model. So what I like to do is I like to put something like, begin Ngswag, and then I like to do end Ngswag. And then what I'll do is I will actually copy paste everything in between here. So as it always happens in between projects, interfaces always change. So sometimes what you need to do is go in here, run it again, select all between your Ngswag, and then paste, and then you always have a single source of truth. A couple other nifty patterns here. So let's go ahead and just go ahead and pull this guy. Let's just pull in a couple. Let me just pull in one or two interfaces here. OK, so let's say I have a sample interface here for this guy. Well, OK. I have begin Ngswag. Swag. OK, so you notice I never want to monkey with the interfaces that are between here, because these have the possibility of changing any time. Your backend goes, oops, I need to add some property, remove some property. So, but oftentimes the UI needs stuff on here that we don't want to change. So that's pretty simple. So you can either do it before or after. You're going to do something like export interface, my interface, extend. Oops. OK. And then we can add something like ID, whatever. So the advantage of this sort of approach, one, is it lets you keep all your Ngswag stuff clean, neat, and you are never monkeying with this stuff. But now it still inherits all its types from here. So you can add all your own properties and then you just use this. And that way, if this change, everything downstream sort of cascades and you still get perfect type safety for that kind of stuff. Pull up my notes here. Okay. Any questions on that? Oh, one more thing. So one thing I also want to call out is that you'll notice by default, all of it. So let me pull in another model right here. A little easier to see here. Something you'll notice that Ngswag Studio does is kind of silly, is you'll notice that it has both a question mark and undefined. This is silly. It's kind of redundant. So what I like to do is you just remove all the undefined because this is essentially the same thing. Now, something that's really interesting is I asked the backend about it. I was like, why are all these properties like undefined? So like a good example is GUID. So we'll get a lot of GUID properties back from our backends. And I know for a fact that GUID is never going to be undefined. So why does Ngswag Studio pull that in? Well, the backend guys have actually said, well, it's actually really hard for the backend guys to actually clarify which properties are undefined or not undefined. And so that's why by default you see this. And even though if you know you're always going to get GUID, this also makes it a little hard. So it's kind of good and bad. So one, it's kind of a pain, like you don't know if you're going to get it or not. But the nice thing about this is this forces you to do null checks everywhere. So like if you need to access that GUID and its potential in there, so it just makes for a lot stabler code, even if you're not sure. So again, this means undefined. This property may or may not exist. And then that'll be useful kind of when we get into strict null checks. Any questions on Swagger, kind of the advanced stuff on around that? Cool. All right, glad it all makes perfect sense. Okay, so you can see here, module, another alternative is export namespace models 2. And I'll show you why this sort of matters in a minute, because sometimes we want the ability to use enums. Now, I'm sure everyone's worked with them, but I'll go over them pretty quick here. So export enum color blue, red, green. Okay, so as you guys know, just an enum is just a discrete, so sort of fixed values here. So if you declare somebody with a type of enum color, an enum color, it is always going to have to compile down to one of these. So this right here is a numeric enum. So if you were to actually compile this to the DOM and you were to call color.blue, it would compile as 1, 2, and 3. Another alternative we can do is called the string enum. It's where we do something like that. All right. Okay. So so now if you were to compile this to the DOM, color.blue will equal blue, and this makes it useful for tracking stuff. Another alternative to enums is a string literal. So export type color equals blue, red, green. Okay, what's the difference between these two? They work more or less the same in terms of type safety, but the difference is you can actually compile these. And let me show you what that looks like. So let's go into a sample component here. I just zeroed everything out. You'll notice that I've created a property called interval time, and I've set it to an enum. And the advantage of this is I can do this dot time interval type, and you can see here, here's all my enumerated properties, right? So then I can do this, and if I console this out, this is going to return whatever the value is. So really, the advantage of casting your enums to the DOM is this gives you full type safety throughout your entire stack. Because Angular isn't super great about type safety in your HTML templates files. Using something like this or returning this back to like a function gives you a lot of type safety on that. All right. Okay. All right, that's that. So let's go ahead. Any questions on that so far?
I have a question, Joe.
Hit me.
So sometimes I try to see if a word, for example, the blue, is included in the text or not. So I try to use the same approach with the interfaces. with the enums, right?
Really
So
hard to
for
hear
example,
you. Could you maybe get a little closer to your mic?
can you hear me?
Yes, better. Thank you.
Okay, so I tried to see if, for example, the text below is included in the text or not. So I tried to use the enum, but I got the error that I cannot use the enum type. I cannot check it against the string value. You know what I mean? So I have a string.
So you'd have something like if, my var, equals this, right? And then it's not working. Okay. So the number one cause of that is you have to make sure that and this is something where TypeScript kind of sucks, is you need to make sure that your enum is actually available. So if we go back to my previous example and I do namespace, okay, you notice it didn't throw any errors, right? It works the same. The difference is namespaces are not compiled. So if I were to try and use this model here, it would blow up because this is just a suggestion now. So another alternative, if you need to use enums, is to just export them outside of like a namespace. The reason why I like to use modules is because I now have one source of truth for this. So what would happen if you were using a namespace, you would actually have some duplicate enums that may fall out of alignment. So you would like import this and use this for passing data around your DOM, and then you'd use this as an interface. But it's possible that you could have something, you could have something change, one of your values change. If you notice, there's no compiler errors for these. So I would just make sure that your enum is someplace that the compiler can actually access, and it's not like wrapped inside a namespace.
Got it. Thank you.
Okay. All right. So next one, fun stuff, are generics. So if you guys haven't worked with generics at all, what generics let you do is essentially pass the type as an argument. So let's create a sample utility function. Export const array to record. Okay. And we're going to have an array. And we want to reuse this. All right. So all right. So we're going to. So if you notice, one of the problems with using any is that if I were to use this function, it wouldn't preserve type safety. So, I'm going to expect, return responsive, whatever. So one thing that we can do is if you use the arrows before or the brackets beforehand, you can actually specify the type as an argument. So if you notice what here is I've said that the type is now going to be inherited. So generic type T, and I'm going to expect an array of type T. So if I go to use this a record, that means that the data coming out of this is going to be properly typed. So let me go ahead and show you. Let's just go ahead and show you real simple. So const record equals as record string T. All right, and then we're going to record. All right, so let's just show you. Let me show you what the response types here. So if you notice, if we look at our response type, it's smart enough to know that I have to pass it an array of type T, and it's going to return me a record of type T. So let's actually go ahead and do that. So we're going to do array dot for each, and this is just a really simple example. X record. Let's see. Actually, we need a unique ID, so let me add another parameter on here. Let's call it ID string ID. Okay. Oops. Okay. So if you notice here, so now I can pass. So the cool thing about this is I've now created a utility function that's usable with any array that follows these common parameters. So you notice I pass an array of type T. It's going to take that array. I pass it a unique ID of whatever the property is, and it is going to return a properly typed record of that stuff. So so this is extremely powerful for when you're building a lot of utility functions, you're doing a lot of stuff. So the other thing I want to call out is this works really well with a pure function. So I keep coming back to pure functions, but these are a really powerful tool in your toolbox. So you notice only inputs and return here. So now I can use this over and over and over. And this is how libraries like Lodash or Ramda work. They all follow this sort of thing. So now I have perfect type safety where any I did. So now here's where things get a little interesting is this, and I can have multiple types. So I can do type y, and I can do type require y. Let's see here. Satisfy the constraints. Okay, so y equals string. Okay. Now this was totally working easier earlier. Record of type k. Hang on, let me go ahead and fix my example here. Okay, so I actually used. Okay. So now we know, let's go ahead and extend it. So now we know that this is, let's assume that we're going to get an array of objects. So let me actually change this to k, I think that. So we're going to do k extends key of t, and then we'll do k. Perfect. Okay, so let me explain what happens here. So now we've just said, hey, this is an array of objects. So I've passed it 2 type arguments. So t is any object, and k is a second argument. But you notice what I've done here is I've said that this is a key of t. So this means, like, if this is an object, what this is going to force you to do is this is perfect type safety. So if you pass it an object and you try to pass it a string value to ID that is not a key of t, it's going to throw a compiler error. So you'll notice. So I could, another alternative is I could do something like equals strings, probably not gonna, yeah, it's gonna throw a little bit of type error. So I can also set defaults for these, but we run enforce type safety. So we look at our type safety now. I'm gonna pass it an array of t with an ID of k, and it's gonna bring me back a perfect record of this. And you notice I can use this now for any array. It's completely agnostic to the perfect type, whatever type's coming out. It doesn't matter. You can pass it any interface, and it's always going to return you a perfect type safe conversion. And this is just a really simple example. Sometimes these get really get really massive in terms of complexity and stuff like that. Again, this is a good way to get type safety for stuff. And you can do some other nifty stuff like equals, models dot, whatever. You can set default types for stuff like that. Any questions on generics?
So whatever type of the array you pass, that's where it grabs what type it's supposed to be. Basically.
Right. So let me actually show you an example of this. So let's do let's see, array.record. Let's pass it. Okay. ID. So this means we need to have an ID. What's going on here? That's type unknown. Object literal mail, and ID is not on type. Okay. So I think I've got a little bit of work to do on my type here, but probably helps when you use the correct types. Okay. So if you notice, I can pass this an array of these types. Okay. And you notice I didn't have to specify the type. Right? I didn't have to go in here, and I didn't have to, t equals whatever. So basically, it knows it's going to take that first argument. It's going to grab the type from that. And if we look at my return response, look here. It knows that the record is going to be ID or whatever that property is, and it's going to return, whatever. So if I do something like, test, actually I didn't do that. Test, you'll notice that, oh, look, now there's my, helps when you're using an interface, but here's my record. So it knows that I can get either one of these. It's actually, look at that. It's actually smart enough to know that because I only had test in one, it could be either string or undefined. So the compiler is actually smart enough to take all your input types, and because you were using generics, it gives you the proper response. So now if I go ahead and add this property to all of these, you'll notice that my return type has now been flattened because it knows it's always getting it. Now this is just because this is an inferred type. So if I did something like, export interface, whatever, and we did ID, string, test, string, and then we did, let's see, const array. Okay. You'll notice, look how it's changed. It's smart enough to now know that it is returning an interface of whatever. So the compiler is really, really smart. And this is how generics are incredibly powerful. So definitely play with these. And definitely like it's kind of a pain when you're dealing with like key of and stuff like that, but like it's really easy to get trapped when you're using a lot of utility functions like this to use any in there, and you lose type safety when you do that. Any other questions?
Yeah, just out of curiosity, for line 16, if you were to replace ID with some bogus string, does it recognize it?
Is it?
Try putting like something.
Oh,
like
I did. Haha.
Yeah.
Ah, look at that.
Okay.
See, so this is the power of, so this is what key of does right here. So if you notice, I tried to use a property that is not found in type whatever, right? So if you look, this is what perfect type safety looks like this function right here. It is impossible for this to blow up. And I'll say this, and as Keith likes to mock me for this, and I fully support the mockery, is that it is the pipe dream of functional programmers everywhere to have an app that if it compiles, it is error-free. Right? Like wouldn't that be awesome? Like, when your app compiles, it is impossible to break. Now, we'll never get there, of course, because in the real world, data is messy, requirements are loose, all that kind of stuff. But that doesn't mean we can't try to get really darn close. And you can say this is a good example of that.
Sure. Just to help me understand this a little bit more,
sure.
Can you just give like a real world example of like when this came into play and like was useful for you?
Okay, so so I have my map project out. Let me see if I can find generics. Perfect. All right. So let me give you an example of a function here. I think I shared this actually a while ago. So on my map project, something I have to do pretty regularly is I have to merge and dedupe arrays. I have two arrays, two object arrays. And I have to do this multiple times. So here's an example of what I did. So if you look, here's my generic, right? T extends object. So I just said, okay, hey, I know my object type T, it has to be an object type. And K has to be a key of T. Okay? So my input array is going to be of type T, and my array to override it is going to be of type T, and my unique ID is going to be of type K. Okay? And then what we do is we go through the logic here, and and look at this sweet, sweet reduce statement. Oh yeah, it's beautiful. I love it. So this is actually, if you notice, this is actually almost identical to the example I showed you earlier, except I wanted that to be more readable, where this, reduce with a closure to get the unique ID is probably not as readable. So if you notice, like I have now, and this saved me tons of time, right? So I've used this in half a dozen different places to do that. So another one down here I have called merge arrays, where I have two arrays and I need to make sure that they're unique. And it's very similar to the above one, but I'm not deduping. So this is an example of how I just built a utility function that we can now use and use over and over. And now these are kind of highly advanced examples where like this one is pretty simple. Like this is actually a pretty common task, right? Converting a record to an array and back again. So I could have another function called convert record to array, and I want to preserve type safety to that. So stuff like that.
Sweet.
I have a question about, so you have T, comma, K extends key of T.
Right.
So do those correspond to the inputs, or what? Like how in depth can that get, I guess?
This can get really deep. And you can also have as many as you want. So you could do, you could also have as many. So for like, if you have some really complex utility functions, these could get deep. And so what it does, if you notice my input down here, so if I do test, if you notice, it's smart enough to pass along the type of array and the key, and I don't even have to I don't even have to worry about it. Like it just works. Like, so if you look at my return response, you'll notice it's going to return me a perfect responsive key test whenever. So the rabbit hole can get kind of deep when you get to this kind of stuff, but this is a very, very powerful in your toolbox. When you like a lot of our apps, we don't find ourselves doing a lot of data manipulation, but some apps we do. And so when you have like a library of these sort of small functions that each do sort of one little thing, and what they do is they roll up to a really huge library that saves you a ton of time. Let me actually show you a really powerful example of this. So this is what I call, this is my markers file for generating markers for my map project, which I showed off last week. And let me show you how big this is. So this is, all right, 300 lines of code. And you'll notice a lot of these are all utility functions. You don't have to pay attention to what the code actually does, but you'll notice export const listing to markers. And so what this does is, I'm not using any generics for this, but what this does is when you have like a library of functions that each do one thing, this is what's called function composition. And it is one of the most powerful tools in the functional programmer's toolbox, because what it does is it lets you assemble small bits and pieces of code on an as-needed basis. And let me show you why this is really powerful. So I have a lot of functions in here that just do one thing. Again, just kind of, absorb it. You don't even know what it is. This one converts property to an HTML marker. This one converts property to a feature collection. This one converts it back again. This one converts it to something else, something else, something else. So what happens is the map is huge, and there's a lot of data conversion going on. And it's in different places. And sometimes I have to convert from like A, B, and C. Sometimes it's A and C. Sometimes it's B and C. Sometimes it's just C. And so what it is when you have a lot of utility functions that each do one thing, you can compose your functions together to get the desired result. And this saved me weeks of time on this project, because early on in the project, the clients were changing requirements on me on like a weekly basis. And so what would happen is they'd say, I want A, B, and C. Now, if I had one big function that was A, B, and C, that'd be great. But then they'd say, oh, I don't want B anymore. Well, guess what I'd have to do? I'd have to go in there and rip out B and change stuff. Well, guess what? I just had to go in there and comment out one line of code, and it was just A and C. But then what would happen is 3 weeks later is I had to build some new feature, and that new feature needed B and C. So I either rewrite all the business logic with that, or I just compose those two functions together to kind of get the result that I need. Save me tons of time, tons of headache. I'm really in love with this sort of pattern because of it just saves my life. Tons of time. If you notice, perfect type safety across the board. Function composition is kind of a really powerful tool in your toolbox. So definitely, once you guys start doing a lot of data transformation, definitely keep that in the back of your head. Any other questions?
Do we ever foresee maybe bringing out some of these utils to how we have that shared Angular components?
Yes.
Somewhere like that.
Great question.
Yeah. In the Angular starter?
Yeah, yep. Angular starter, yeah.
Well, you've called me out, because the right answer should be yes. And the reality is sometimes it's really hard to keep track of what we're using and move library back. So far, most of those functions have been kind of specific to the app, but like that merge dedupe one.
Yeah, that one looked nice.
That one is actually really handy, and it took me 4 or 5 hours to write that one and get it perfect. It'd be nice to say that. So feel free.
That's a flex. That would take me a couple days.
So that's a really powerful. Yeah. So that's something we need to do better. So and that's like an open-ended question. It's like, how do we do code sharing as a consulting company? I think the starter is a really powerful tool in our toolbox. I haven't covered Bit yet, which I will at a future time. Let's just say it's something I'm not totally satisfied with how we do. There's a lot of opportunity. We sort of got we're on the path, and we know where we're going to go. We've got this, which is, and the hard part is I just don't have time. So I'm at 150% capacity with getting paid, and so helping us do multipliers. It's really hard to even do these front end Fridays because it takes me a couple hours to prepare. So I'm hoping that as the team grows, and this is something that the business is aware of, is a lot of my value is going to be in a lot of these multiplier stuff. So our starter saves us weeks of work, and a lot of the utility libraries and stuff like that. So if we can keep building that up and up and up and up, it's going to save us a ton of time. It's going to increase our profitability, and that's kind of where we're hoping to go, kind of for that. So
that'd be a good next topic for Front End Friday. Just how some brainstorming on that.
Yeah, how we do that. So I think Rusty actually gets the award for first contribution to the my library. Rusty, that's pretty impressive considering Russell's been here for 3 years. So if we don't want to rub it in,
I kind of think he wears that as a badge of honor that he hasn't contributed to that.
I mean, it's not totally fair. He's helping me maintain the starter, but like as we and the reality is we're all building tons of components. So I showed off the map component last week. Guess what? You know, when this project closes down, I'm bringing that into our starter. So that way, next time we have to do an Azure Maps implementation, guess what? We've already saved 50% of the work. And the nice thing is all the map vendors are so similar that we could easily leverage a lot, even if we don't. So coming back to those utility functions. So even if we have switched to Azure Maps, guess what? I could probably reuse about 50% of the code in that, just because all the logic are in small utility functions that just deal with, you know, single responsibility principle. So pretty powerful toolbox. All right.
Have you talked about like type union and stuff yet?
That's next on my list. We'll do those.
I just got excited because that was the one thing that you taught me that was like super useful for.
I know it's pretty rad,
right?
And I'll get into Typeguards as well. Okay, so let me show you one more pattern that I really like, and it seems small. When I show it to you, it's gonna make total sense, but it has like changed my life. Okay, so if you notice when you're building, so when you look at my file here, I want you to notice something. I have a good example here. So notice that I have undefined and null in my function call. And this is a really big deal. Let me show you why this is important. So let's go back to our previous example. I am going to pull in, I'm going to say this has the potential to be undefined. And I should probably do it for this one too, just here. And null. So what's going on here? Why would I, fix my type safety here. Okay. So why would I do this? Okay, so why would I accept input undefined or null? And it should throw an error. Oh, it's not. It should throw it. I might be outside the compiler here. Okay, so keep in mind, if you look, I just show you, I have hundreds and hundreds of utility functions that do kinds of stuff. And in the map product, one of the problems I have is all my operations are asynchronous. So I have API calls running in parallel, running in sequential. I have 1, 2, 3. And so at any given time, I may or may not have the data that I have. Sometimes maybe null, maybe the data is malformed. And the problem is it becomes really hard to manage what's where. So when you do something like this, you are going to do if not are, you're going to add a null check everywhere. Return. So this is a really small thing that is a really big thing. So what I've done is I have now added perfect null and nil handling to this function. So you can throw literally anything at this function, and it is always going to come back with a result that won't blow up. So imagine for a moment that I did not have this, and this got handled a null, right? And I don't know why my compiler is not throwing an error. It really should. So what happens when it tries to call for each on a null value? It's going to blow up. Right? So by adding this response here, this guarantees that this utility function is always going to work. It's not going to blow up. It's not going to throw a type error. And you can throw literally anything at it. And in a really big app where you have a lot of data flowing that's in different states and it's being modified, when you have a giant library of functions like this that are each sort of managing their own internal state in terms of like null and undefined handling, you have an incredibly stable app, right? So now you've got the compositional benefits of function composition, but now because each composition, and you look, I use this pattern a lot. So here's an example, like, boom, we don't, I should probably here. Oh, dot length. There we go. Okay, proper thing. So you notice I use this pattern a lot. So here's an example here. This one, not type safe. So here's another example right here. Like you notice I have multiple inputs here, and I say, hey, if I don't get both of my inputs, whatever my default value, so this is always going to work. So in a lot of times where you're transforming data, there's always like a fallback that you can use, and that's this. So I definitely recommend you consider this pattern as you guys are starting to build a lot of your libraries for stuff. Any questions so far?
I have a question about that pattern. Wouldn't that kind of let, I mean, if you're just returning an empty object, wouldn't that affect things down the line and possibly be hard to track the error?
Okay. Fantastic question. Okay, so this is an example as if I always want a response. So another example is to do this. Okay, so if we go back to my previous example, I could do, so, you know, const result equals, you know, ID. So if we look at my response type, so I'm not, should see here. I'm not sure why it's not picking up my, oh, I probably, let me go ahead, let's see if it picks up when I save it. Okay, so I'm running into an issue with it, so it should be, I'm not sure why it's not giving me proper type response. I wonder if it's because, here we go. Well, we'll just set the assertion. Okay, so let's try, hold on, let's try. Is it smart enough to tell me? Let me see here. Okay, so I'm not sure why the compiler, just because I didn't spend 5 hours kind of getting this result. So what happens is null has the ability to be both your record of type T and null. So you could do something like this. You know, whatever, right? So in the example let's say in the example that you brought up, I don't want results returned. Like if for some reason that my input is malformed, whatever, I can return null, and then that lets all downstream subscribers do a null check to see if whatever, and you can have, else, do something like that. Does that make sense? It's totally on a case by case basis.
Yeah, so it's kind of like a async await. You would just test the result, I guess, to make sure it's there. Okay.
Yep, exactly right. So I think I'm doing this a couple of examples, and I don't want to dig through kind of old code just because I got 20 minutes left and I got cool stuff I want to cover. But that's a great example. So sometimes you might want stuff that's consuming this to know. I always want a result back. So like an empty array, like this means that assignable. Okay. Well, regardless, I'm not sure why I busted that. So you might want downstream subscribers of this to always get something back, right? So then that way the downstream subscribers don't have to do their own null checks. Or you may say downstream subscribers need to know if something's busted. And so this is like, it's on a case by case basis. Also, you can have a lot more conditionals in here. So you could say if not array, you could have, if, array dot length 1, you could return. So basically, you're now handling all your edge cases and your side effects and all that kind of stuff. And so it's okay, it's okay. And it's okay if you have a lot of this. But the point is you want, when people call this, you need a bulletproof response. So this is like it is not possible for this function to throw an error or have side effects, doesn't meet state, all that kind of fun stuff. So this is like a really powerful tool. Any other questions?
Yeah, for this union with the nulls, I've kind of done it like a lot in the models that I've been using in models.ts.
Okay.
And I'm just thinking like, is that being too defensive or too specific at this point to put it like to have that union in that models? Because the thing is like, I don't really know for sure if I need it. Like basically. Okay.
Right. Yeah. Okay. So let me show you. So great conversation. So if you notice, so let's go ahead and get rid of this. So you notice this is valid, right? The Typescript compiler is not throwing an error. But if we get rid of, all right, so I think, why is my compiler not working? Okay, so just pretend with me, just because I think I'm in a utility function. So if you notice, by returning this will now, it really bugs me that this is not working, and I wonder why. Okay, so this should theoretically throw a squiggly, and I'm not quite sure. Let's go ahead and because my return response. Hang on here. Oh. Okay, so I don't know why it's not throwing a red squiggly, but now this is like this should not accept a null result, right?
Yeah.
So this should always require this. So it's on a case per case basis. So if you're dealing, so in the case of your example, like, yeah, this, like, I always know that this function should always have response. You can do something like this where it's not undefined or null. And then everyone who tries to use it will be forced by the compiler to use the correct inputs. And that's on a case-by-case basis. So in the case of our Atom project, I am regularly dealing with things like I have properties that, because like good example, I have two models that get passed into this function. Some have properties that the other one doesn't. And so like I want to be able to handle all the things I can throw at it, and without knowing which model it is. And so something like this, where it's, that works pretty well. Is it this? Oh, it bugs me. This bugs me so much. Why is it? Come on, compiler, make me happy. Okay, well, whatever. Both work equally well. But the advantage to the flexible one is one, you don't have to use the knife every time. And a lot of that depends on if you have a lot of data flowing around and you don't always know if it's going to be good or not, or different models or different stuff. Adding some defensive coding like that can help you kind of handle that. So, because
Okay.
Yep. Okay. All right. Any other questions? Perfect. All right, so let's go on to our next type. We're going to go on to union types. Okay, so let's go ahead. Let's call it type property equals, okay, string number. Okay, so anytime you guys see this guy, we now have a union type. And let me give you another example of what this can look like. Whatever test, okay? It can also look like this. Okay, so now what we have told the compiler is that I have an array that's going to have two different types in here. Some simple example. So we could do type color equals string number. A couple of examples. I can also do type color to more advanced types. Okay, so you've noticed here, this is essentially an OR. Right, and this lets you mix any number of types. Now, where does this get useful? So, in the Azure Maps project, I get an array of data back that can contain. So let me give you a perfect example here. So let me go ahead and pull this over here. All right, so let me give you an example of why this is really powerful. So here's my Azure Map. No, all right, okay. So let me see. Okay, so here's my type ahead. And do I have a good example here? No, let's try, hang on, I'm trying if I can find a good example here. Orange. All right, well, it's not a great example here because I'm getting one type stack. So basically what's happening here is you notice here's my type ahead that I built for Azure Maps. And you notice each one of these types, so this one is a type county, but I can also get type city back. I can also get a type zip code back. Now, each one of these return responses are different properties, different structures, different everything. And so what my union type is, it looks a lot like this. So basically, the API is returning me different data set, a union of data sets. And so how do I preserve type safety for that? Well, it looks like this. And so that leads me into my next topic of how do I preserve type safety when I have a union type. Any questions on unions? I mean, it's pretty straightforward. No questions? Okay, perfect. All right, so our next topic of conversation is called the type guard. So basically, let's go ahead and let's make my type of, so I'm gonna have an array of type color, which could be either a string or a number. So let's say I was to do, let's see, hold on. Const array, color. All right, test, 1, 2, 3, 4, 5, true. Should throw an error. Perfect, okay, now the compiler is working for me. So you notice I now have a union type where multiple types are supported here. And so it'll set input of type or number, and if I wanted to, that makes that go away. Well, I don't want that. Okay, so perfect. So I've got good type safety on this. So I'll go ahead and remove this. Okay, so now let's go ahead and loop over this. For each. Next. All right, so compiler smart enough. So what's the operation that can I do? X.car. Okay, all right. So if you notice, I want to do car at 0. Okay, so the problem with this function does not exist on type. So if you notice, here's why. This is a string operator only, right? I can't use char at 0 because what if it's a number? TypeScript's smart enough to know, hey, you've got a union type here. And if you try to call char at or char at on a number, your app's going to blow up. So how do we handle that? And this is where Typeguards come into play. So let's do it. Export const is string. OK, so we're going to call it value unknown. And I'll explain this in a minute. And then we're going to do type of value string. OK, so now here's where the secret sauce is. So this is, you notice it's a function. It's going to take something, anything, you can throw out anything at all. And this is actually going to return a Boolean. So if we look at it, it's going to return true or false, right? This is just shorthand for, you could do something like, if, type of equals string true, false. OK, now here's where the secret sauce is. Value is string. OK, so now what we have done is we have told, this is TypeScript. So now we have told TypeScript that, OK, let me back up a little bit. So you notice I've used any here, unknown instead of any here. What's the difference between the two? They're very similar. Unknown is the non-type permissive version of any. So basically, you can assign anything to value, but then TypeScript will not let you use this again unless you do something like this to tell TypeScript what the data is. In this case, it really doesn't matter because I just told it it's a string. OK, so now I've said, TypeScript, I am telling you for sure, I pinky swear that the response, that if it passes this test, it's going to be a string. Now, keep in mind, this is an assertion. So if you screw something up, TypeScript's not going to know. So what if I did something like this? Right? I have now essentially had a bad, so a number will pass this test, but you've just told TypeScript it's a string. So keep in mind, like a type guard is like on the honor system. Does that make sense? OK, so, and then, OK, so I've said I totally guarantee that this is, when you see this function, it's going to be a string. And then you have your conditional in here for whatever it needs to pass. So this is a really simple example. I'll show you how to use this with an interface. So now what we can do if is string x. Hang on. All right, x dot. Now you notice TypeScript now knows that this is a string, right? So now if I put this guy in here, it works. So now this is how Typeguards give me perfect type safety for something like this. So now when it's looping over, and now I could do something equivalent like this called is number. Okay, number.
So what's the difference between value is number and just saying it's number? It's going to be a number, I guess.
OK, the advantage of this is this tells the compiler what the data is. So when you wrap, so let me just go ahead and get rid of this guy here. So when you use an if statement with a type guard, anytime you try to, you've now told TypeScript what X is. So if you notice, the type X here says type color. TypeScript does not yet know what this is. However, if I look in here, now TypeScript knows this is type equals string.
I mean the actual where you actually put value is number up in
sure
into the, like, why would you, I guess I don't understand what value is instead of just typing it as number.
This could be, it could be X, doesn't matter. This is just whatever your input property is. And this would be equivalent to so this nope. Okay. So basically, are you saying, like, why would I use a type guard instead of something like this?
Is that what that is? That's the type guard. So I guess I normally just see it as it would be typed as string, like you're telling it, okay, I'm going to return a string.
Right. Well, the reason why is it doesn't know what type this is. So
okay.
I have two types in here. So X could be either a string or a number. So what a type guard does, it's a way of separating out union types to make it so you can operate on them without blowing up your app. And let me show you, and I think I know where you're going with this. So let me show you another example of this. Okay, so is type is whatever. Okay, so if you notice, I'm now making a type guard for a more complex object. Okay, so now I need to say, let's see, X, let's see, how do I do this? I haven't done one of these in a while.
You could do whatever validation you needed to make sure
right,
that
type of
going to interact with the method you call on it later, right?
So yeah, so let's see, X dot test. This is probably gonna throw an error. Undefined. All right. All right. So ignore for a moment that I forget. I forget the pattern right off the top of my head that makes this valid. So I might see. Might be appropriate to do something like this in this case. Okay. So in this case, here's the test, right? So if it passes, and this test is whatever you want it to be. So it's possible. So if you notice, both of these interfaces would pass the test. So let's call this, color, right? So what would happen is this test says basically if this property exists on this input, then we know for a fact that this is type whatever. And so now when I'm working with union types, I can kind of operate on that. Go ahead. All right, so I could do, X, console.log X times 2. Okay, so now I can do a math operation, which you can't do on, actually, I've never tried to do a math operation on a string. So this actually work? Let's find out. Aha, okay, perfect. So perfect example. So now what we've done is when you have union types, this lets you operate on, and then your last condition can be, console.error. I have no idea what this is. Or you could return null or something like that. Okay. And I got 4 minutes left. Okay, so that's type guards. Any questions on type guards? Cool.
So let's say I do have a question. So let's say you want, like, is whatever has a bunch of methods that you're going to need to call with it, and it needs to have X, Y, and Z to be a full whatever. Right? Would you approve of doing that type of validation inside this type guard?
Absolutely. So again, this is just shorthand. So we could do something like this, right? So return false. So we'll set the default return type to false, and then you could have like a big honking if statement in here, right? And then else if, and you could have a ton of conditions. Return true, whatever. This is just this is your code checking whatever that pattern is. And this can be absolutely anything you want it to be. So it can be as big or as complex. So this is obviously a real simple example, but type guards can get really big and complex. So like in my Azure Maps example, I'm actually using a type guard against enumerations. So, if it's enumeration 1, 2, 3, or 5, and it gives me really good type safety. So again, this is all up to you. It's sort of like on the honor system. All right. Okay. So let me show you a couple of nifty mix-ins, because I've only got. Let me go over something I think is really, really important, and I'm not going to have time to cover this in depth. But if you look inside our typescript.base.config.json, we have something in here that is huge called strict null checks. If you're new to working in InterSol, this is going to be a huge frustration. I think a lot of the people on the call have worked here long enough that they have dealt with this. So I'm just going to briefly cover this. What strict null checks does is it does exactly that. It does not allow you to access nested properties or operate on things that may or may not be null. When you first turn this on, it blows your app sky high. And then after you've been working on it for a few months, you realize, oh my gosh, 70% of the errors, breaking changes in my app are due to poor null check handling. And so this is why this is on.
So nice.
This is like one of the, thank you. You're hated it first, and then you realize, oh my gosh, this does not let me make mistakes. So in the case of, and I'm not going to have time for this. So let's say I have a really nested project, test 2, tests string. So in the case of this example right here, if I tried to call, whatever.test2.test, you notice this object may or may not be here. So if you try to access a function or a property on something that does not exist, your app blows up and you've just killed everything. So then you have to wrap a lot of your access properties, and you have to check, does this exist? On one hand, it's kind of annoying that you have to wrap a lot of your function calls in null checks, but then you realize, oh my gosh, my app does not blow up anymore. This is a fantastic thing. So I can cover these more in depth because I'm down to 1 minute, but I can cover these more in depth later. But I just want to make you aware, like, hey, it says, hey, when you see that error, object is possibly undefined. That's TypeScript telling you, hey, if you try to access this property and it doesn't exist, your app is going to blow up. And I'm going to prevent you from doing that because I love you. You're welcome. So, all right. So I have like 1 minute left. Any other questions, comments?
I mean, I wouldn't mind flexing and showing my the one thing, the thing that I built that was pure and single use, and was specific to Civic, but could occur elsewhere.
Let's yeah, we could have like code show off time at a future session. That might be kind of fun. All right, let me go ahead and stop share here. Okay, well, I just want to be respectful of everyone's time because I know it's Friday and taking up a whole hour is a lot of time. And so I'm going to go ahead and end the session. And as always, guys, if you think of like if I didn't cover anything in depth, or you'd like to have more details about strict null checks or anything else I didn't cover in depth, please feel free to reach out. I'm happy to do one-on-ones. And then for if I get a couple of people saying, oh, hey, I'd love to have more experience writing utility functions, what can I do that? I'm actually keeping a list of stuff to cover for Fridays. So please let me know. And thanks everyone for attending.